Here we have three different systems of equations. Each set has a green line and a red line. And we're going to work on classifying them, telling what type they are. Now the first thing we want to decide, are they consistent or are they inconsistent? Now all consistent means is, do the lines touch? So these ones touch right there. This one, these two lines, well, they're not perfectly parallel, but they are supposed to be. Well, parallel, which means that they will never touch. So the difference between these are, this is consistent. This one is inconsistent. This last set, we have two lines drawn right over top of each other. So we have, essentially, they touch everywhere. So that is a consistent set. So these ones are consistent. The next part we ask is dependent or independent. Now on the inconsistent one, that's all we need for the answer, is inconsistent. But on the two consistent lines, we're going to separate the two as dependent or independent. Now, these two are essentially two different lines. So they are consistent, independent. These two are essentially the same line, one over top of each other. So we call these ones dependent. So that's the three different types. Now how do we figure out, there's a few more things you need to know from each type. Let's look at the slopes of the lines first. Now remember, slope is the angle that the line is at. These two lines have different slopes because they're sitting at two different angles. So that means that the slope of the green line does not equal the slope of the red line. At the next one, they're parallel lines. Now parallel lines always have the same slope. So the slope of the first line is exactly equal to the slope of the second line. And our last ones, since they are essentially the same line right over top of each other, the slope of the first line is exactly the same as the slope of the second line. So if you have two lines, if you have a different slope on your two lines, you have a consistent independent system. Otherwise, you have one of the other two, either inconsistent or consistent dependent. Now, next up in figuring this out is how do we separate the other two? Well, we're going to look at the y-intercept. Now, remember, y-intercept is where it crosses the y-axis. So in our middle one here, we have two different y-intercepts. That means y-intercept from the first line is not equal to the y-intercept from the second line. Two different y-intercepts. Over here on the consistent dependent system, both lines cross the y-axis at the exact same spot, because once again, they are essentially the same line. That means the y-intercept from the first one is exactly the same as the y-intercept from the second one. And the consistent independent, your y-intercept can be the same, or it could be different. We don't know which it is. Now, the last part to these types of systems is how many solutions are there? Now, all a solution is how many times do the lines touch? This one touches once, so it has one solution. The two parallel lines in the inconsistent system will never touch, so there are no solutions. And on my consistent dependent system, remember, they're essentially the same line, so the lines are touching right there and 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 so on and so on. They touch everywhere along the line, so you have infinite solutions. That's the difference between the three different systems.